Hello and welcome to grade 11 physics. Um, this introductory lesson, or lesson number 1, is basically a review or a review of skills that you're going to need to go, as you go through the curriculum. The majority of skills are grade 10 math skills. People who find physics difficult are the people that struggle with math. So if you are confident with your math skills, your grade 10 math skills, that's all you need, then you will do just fine with the physics. So I'm going to go through some of the stuff you should know. It's stuff that I expect you to know, and if not, you're going to have to do a little bit more review. So you can kind of zip through the stuff that you already feel comfortable with and slow down and take a look at some of the stuff that you're not so comfortable with. All right, so it's up to you to make sure you know the material that's covered in here. So starting off here, physics is all around us. It asks those why questions and provides some answers. So what are we going to do this year? We're going to investigate some of the why questions, and hopefully you do have some why questions or they arise as we go through. And we're going to use those why questions to help learn some stuff about physics. And what it's going to do is going to teach you a process to kind of eliminate and figure out what's actually involved here. So this is where physics, it has that reputation of a hard subject. Hey, I hear it all the time where students go, oh, the calculating of physics, that's hard. The reason it's hard is because of the expectation of math skills, okay? I expect you to know grade 10 math. We don't have the time to go back and teach grade 10 math except for this introductory lesson here. The stronger at math you are, the easier it is to do the calculations. Now, if you're not strong with math, you're still going to be successful in physics, but that's going to be the frustrating part, will be the math. I'm not going to lie, I'm telling you straight up. Okay, there are a lot of calculations, or different types of calculations, and I'm going to try to help you out as we go through this. Okay. So, just remember the golden rule of mathematics. It's very, very important because there is a lot of algebra involved in physics. All right, so if you're comfortable with your grade 9 algebra skills, then you should be comfortable or ready to go with the physics course. So the golden rule, whatever you do to one side, so whatever you do to one side of the equation, you must do the same to the other. The same to the other. All right. So if you go through and your algebra skills are as such that you're comfortable with that statement, then you'll get along just fine. So I have a couple of algebra examples here. And they involve not having any numbers. Okay, so let's talk about isolating. And this first one wants to isolate for the value of t. So we need to get t by itself. So in order to isolate for t, we need to get rid of any adding or subtracting. So that v1 needs to be removed. So I'm going to subtract v1 to get rid of it because it's being added or subtracted. I've got to do the same to the other side. Inverse operation gets rid of those. So I have v2 minus v1. So the 2 and 1 are what we call subscripts, and we're going to use subscripts quite a bit in this course. So you get rid of any adding or subtracting. Then you get rid of any multiplying or dividing. So here, the t and the a are being multiplied. So the opposite would be to divide both sides by a. Inverse operation. So we end up with v2 minus v1 divided by a is equal to t. All right. So if you're comfortable with that, then your algebra skills are where they need to be. Okay. Next one. I want to solve for d. All right. Solving for d, again, there it is there. I want to get rid of any adding or subtracting. So in this case, I'm going to subtract v1 squared, and I have to do it from both sides. Inverse operation gets rid of that. So I'm ending up with v2 squared minus v1 squared, and I'm left with 2ad. The 2 and the a and the d are all being multiplied together. So the opposite of multiplying is dividing. So I'm going to divide both sides. Inverse operation. I end up with v2 squared minus v1 squared over 2a is equal to d. And there we are, all isolated. Okay? Moving along, I want to talk about your calculator. Okay? You're going to be required to use a calculator in this course, so it's very important that you have a calculator that you'll have throughout the whole unit. you need to know how to use it, okay? And that is the important part. So how do you enter in exponential notation, or exponents, I should say? All right, so if you want to enter in exponents, most calculators, there are two buttons on the calculator, x to the y, or the caret top button. All right, so if you have 5 cubed or 10.2 squared, we're just using our exponents. So 5 cubed with the calculator, you should be able to get 125. And 10.2 squared, 10.2, and either you're going to have a square button or you do it to the exponent 2, and you get 104.04. So that is the exponents button. Now, from science courses, you need to know exponential notation, and these are not the same. Exponential or scientific notation, I guess. Exponential or scientific notation. Very, very important, because when you're working in chemistry or physics, okay, scientific notation allows us to deal with very big numbers and very small numbers. So what does this look like, this notation? The notation is going to look like this: 2 times 10 cubed, or 3.1 times 10 to the negative 6. Okay? These are not the same. Okay? These notations are not the same notation. They are completely different. One is an exponent on how many times to repeat something. The other one is telling you how many times 10 is being multiplied to the original number. So on your calculator, you should have, if you need to find it, an EE button, or some calculators have a times 10 to the Y button. So you need to find that on your calculator. We're going to go through and talk about how to use it in the next couple of slides. All right, big difference between the two. So scientific notation and expanded form. So let's go from scientific notation to expanded. Oops. Expanded on this side, and then we'll go expanded scientific notation. All right, so we'll do this in 2 columns here. So I just want to move between one and the other. So scientific notations, a couple examples. If we had 3.1 times 10 to the, let's go 4th, 4.65 times 10 cubed, and 7.98 times 10 to the negative 6. And finally, let's do 10.38 times 10 to the negative 2. All right, so there are some examples of scientific notation. We're not even at the calculator stage yet. I just want to be able to move from one form to the other, because sometimes the back of the book will give answers in scientific notation, sometimes they'll be in expanded. So you need to be able to compare and see whether you have the correct answer. Positive exponents, okay, so when I talk about positive exponents, I'm talking about this exponent right there on the 10. Move the decimal to the right. It makes the number larger. So you may not want to write this down till you watch what I do here, because I'm going to cheat. I'm going to put the decimal below. So I have 3.1. I need to move the decimal 4 places to the right. That's what that tells me. So I'm going to move it here, 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 and here. So this is where the decimal is going to end up. Those blank spaces, I have to put placeholders in, and our placeholders are zeros. Okay, so just to clean that up, 3.1 times 10 to the 4th is actually 31,000. All right, so doing it a little bit quicker, okay, I've got the exponent 3. That means I'm going to move the decimal place 3 to the right. So 6 would be 1, 5 is 2, and I need a placeholder, 3. So 4.65 times 10 to the 3 is 4,650. All right. Next one. If it's a negative exponent, you're going to go to the left. So positive, we move right. Negative, you move left. Okay, so that means that I need to move the decimal place 6 to the left, so I'm going to have a really small number. If I move it over 1, I'll have 0.7, and I got to move it over 5 times, so that means I'll have 5 zeros. So 1, 2, 3, 4, 5, 7, 9, 8. Okay, so let's just take a look at that for a second. The decimal started here between the 7 and the 9. If I count over to where I ended it, 1, 2, 3, 4, 5, 6. So it ended up in the right location. Okay, so 7.98 times 10 to the negative 6 is 0.0000798. The next one, I'm going to move it 2 to the left. So that means I have a 10 out front, so I'm going to move it 2 spaces, and this one turns out just to be 0.1038. And there we are. Going the other way then, if I had 3,450,900, and the second one, let's go 49, 1, 2, 3, 1, 2, 3, 2, 3. So that's a billion. 3 if I had 0.058. And the last one, 0.12329. All right, so moving those to scientific notation. Typically, when you go with 1 decimal place, and I'll talk about a little bit later as to engineering works a little bit different, but typically we are moving the decimal so that we have 1 decimal place. So we want 3.45 as our result. So it'd be 3.4509 times 10. How many places do we have to move it? Well, it's a bigger number, so it's going to be a positive exponent. And it started down here, so I moved it once, twice, 3, 4, 5, 6. So it becomes 3.4509 times 10 to the 6th. Similarly, I want my decimal to be right here. I want 4.9. So 4.9 times 10. Now you got to count it out. So 3, 6, 9, 10. Okay. So it'd be to the exponent positive 10. When you have small numbers, I want 5.8 because you want, normally you just want the 1 number in front of the decimal. So 5.8 times 10, because it was a smaller number, it'll be a negative exponent. So I moved it once, I moved it twice, so it'd be to the exponent negative 2. And the last example here, 2.9, ends up there, the decimal, so moving it over once, twice, 3, 4 times. So I end up with 2.9 times 10 to the negative 4. Okay, so there we have converting between the two. So one of the worksheets I have for you is practicing that. You want to pick and choose enough that you get comfortable and feel like you can do that blindfolded. Because like I said, the answer's in the back of the book. Sometimes they're in scientific notation, sometimes they're in expanded form. There's no consistency, so you do need to be able to go back and forth between the two in order to check your answers.